Okay, so that's the complete plan, the incomplete elevation, and now I'm just going to start by drawing parts of the trimetric projection as well as finishing off the elevation. Okay, so I'm going to take up and again, what I'm explaining here to my class is this is the full solution. So you have the full solution. So I'm going to start by getting this line and then the apex of the pyramid. So I'll have all points that we need of the pyramid first, and then I'll build a hexagon around it. Okay, so this point here, we bring that straight up. I already have a construction line from that up. Same here, and then the center point, this point here, is also visible. I have a construction line for that. So I have construction lines for all of the points I need. This point here, where it's already been taken down at 30 degrees, where it intersects this point, that's one of the points I'm looking for. This point here, I'm just going to extend it down to the middle line. So that's that point. And then this point meets it. So that point, they meet, that's one point. They meet there, and they meet there. So that's the information, all the information I need to draw the two ground lines that are visible in this, this pictorial view. Now, if I want the apex, so this is the apex and it's going to exist on that line. This is the apex in the elevation. So I'll just bring the apex from the elevation down. So there it is. Now I'm certainly not going to harden this in yet, so I'm going to leave the sidelines of this pyramid as construction for the time being. So there's the pyramid, but of course we're only going to see certain aspects of those sidelines. And then the hexagon, the hexagonal prism. So I'm going to label the 6 top points of the upper surface. I'll put those same labels up here. Get that out of the way. I'll put those same labels up here. So I'm going to start by labeling this as A. So we already have A, B, C. I'll go with E, E, F, G, H, and I. So to transfer those same labels up here, I, as we look in from the left hand side, this would be the point I. D and H are directly in front of one another, so that would be D comma H. E and G, so this would be E comma G. And F would be out on its own, so that would be the point F. So now it's just a case of bringing I down at 30 degrees and I straight up to intersect, and doing that for all of the points. I. D. Extend the E line down. Sorry, should use that color. G and E are on the same line. So there's all 6 points. Don't forget parallel lines are parallel in every view. So if D to E is parallel to H to G in plan, well then that would mean that D to E will be parallel to H to G in the pictorial view. Parallel lines are parallel in every view. That's going to be a very useful rule now in a few minutes. Okay. So the lines that are visible, the lines that we will see will be this one. Again, I don't know where it ends just yet, so I like to just start off by hardening portions of it, just so we kind of get an idea of the visuals of how it's going to intersect. So that's a nice start to that. So now we're going to continue on with this part C. And right, let's look at what we have been given in the question. And what I mean by that is, say I've labeled this line here F, okay? So this is the side line of the hexagonal prism. And because we had an edge view of this side of the pyramid, we can see exactly where that line enters this side of the prism. So we have a start point and an end point for that line. So therefore, out of all of the lines coming down from the prism, F is the only one that I have an end point that I can use, that I'll see the whole line of. So that's the end point of it there. So I'm going to extend it down to the F line in my pictorial view. And that's the first full line that I can harden in. All right? Because we had a start point and we had an end point. So that's the first line that I can harden in. And again, keep referring back to this drawing here. So now that line is complete. We have it. Okay? Next, what I would like to get, as I look at this drawing, I think this surface here is very achievable. I think we should be able to get this complete surface next. Okay, so I have the two start points of it in the incomplete elevation, but I don't have the end points. In plan, I have a full edge view of the surface, so that's very useful. So I'm going to use the rule that I've just talked about. Parallel lines are parallel in every view. Okay, so if you just watch this, please. So with my 45-degree set square, because my plan is orientated at 45 degrees, I can just extend this, this line here out at 45 degrees across the surface that it intersects with, okay? So just extend that line out. Okay, you could extend it out to the front like I did here, but really it's this point here I'm looking for. So when I extend this, the end point of G and H out to hit the surface that it's intersecting with, now I can use that information. Now I have a height at where those points intersect that surface. So I'm going to bring that point up to that line in my pictorial view, because remember this line here is represented by this line from A to the apex. So now I have a height for those 2 points. And if you remember, the general rule is parallel lines are parallel in every view. So the baseline of my pyramid is parallel to that end point of that surface. So they're parallel in the plan. So therefore they're going to be parallel in this drawing here as well. So that's at a 30-degree angle. So now if I just go at a 30-degree angle from the height that I already have them at, now I have the end points of both lines. So now I can harden in. H goes all the way down to its end point, and G goes all the way down to its end point. So now there's that surface complete. Okay, all because of the simple rule, the parallel lines are parallel in every view. So the next point that I want to find is this one here. Okay, now that point in this drawing is in line with a vertical construction, which is really no good to me, okay? But what I can use here is the fact that this is a symmetrical drawing. It's symmetrical across a 45-degree axis here and a 45-degree axis there. Therefore, if I find this point, I can just go parallel again to the base to get the same point here, because they're both parallel to the base angle. So using this side again of the pyramid, where the side intersects with the side of the hexagonal prism, I can bring that up to where it intersects with the side of the cone. Again, I'll just put a point there in black so it's easy to determine. So now I have a height for that point. And again, we're using the rule of parallel lines are parallel in every view. So just to be very clear here, I'm saying that that line there is directly across from that point there, and that construction line is parallel to that baseline. So again, parallel lines are parallel in every view. So if we go parallel to that baseline of the prism or the pyramid in plan, I can take that height parallel across, giving me the exact point I'm looking for there. So now I have it. So now that point hardens up there and there to the endpoints of the G and the F line. Okay, and again, remember there's no hidden detail in a pictorial view, so you wouldn't finish off hidden detail there. So now we have all but finished that element here. So we're going to again use the rule of parallel lines are parallel in every view. And how we're going to use them this time is because again here we have a 45-degree angle from that point to that point, which is parallel to that baseline of the cone. So again, this is a rule that we can really exploit in this drawing. So there is the base angle of the pyramid here. So I can just go parallel at 30 degrees to get the same point on this side of the drawing. So there we go.
Just go back to show where you got that first point.
No problem, yeah. Okay, and just finish that. Now again, if you look, just to finish that last part off there, where it disappears behind, that is correct because it matches the graphic, okay? So now we have the pictorial view complete, just a case of bringing our heights up to the elevation and finishing that off. All right, so for example, we have the end point now for the H line. So bring it up to the H line. We have the end point for the G line. Bring it up to the G line. We have that end height for that side of the pyramid. Likewise over here. So we have all the points nearly now that we need. And then it's a case of just hardening in. So that's the end point for the H line. The end point for the G line. The side of the pyramid. And again, and that's what your drawing should look like, okay? That's that drawing completely finishing. And again, the question says, note it is not necessary to include hidden detail because you never have to include hidden detail in a pictorial view. So you wouldn't bother with the hidden detail towards the back side of that drawing. Okay, and that's the 2015 axonometric projection question finished.